Hi guys, welcome to Basic Bit. Today is December 12th and the problem we're working on is smallest subtree with all the deepest nodes. Given the root of a binary tree, the depth of each node is the shortest distance to the root. We want to return the smallest subtree that contains all of the deepest nodes in the original tree. So let's take a look at the example tree right here. So the depth of each of these nodes depends on the distance between that node and the root node. So the root node has a depth of 0, 5 and 1 would each have a depth of 1, 6, 2, 0, and 8 have depths of 2, and 7 and 4 have depths of 3. So 7 and 4 are the deepest nodes, and the common ancestor of these two nodes is 2. So 2 is the node that we want to return. There's going to be two steps in solving this problem. The first step would be to recursively go through this entire tree and label each of these nodes with their depths. Once we know the depth of each of these nodes, we can write another recursive function that goes bottom up, starting from the leaf nodes. We can look at the depth of the left node and the depth of the right node. And if the depth of either the left or right node is equal to the maximum depth, then we can keep track of the root node of this subtree as a temporary solution. So we can work our way up the tree, starting from the leaves up to the root of the tree, while keeping track of what is the common parent of the nodes that have the maximum depth. First, we're going to want to create a dictionary that keeps track of the depth of all of the nodes in the tree. So we're going to start with the empty dictionary, and then let's define a function that will get the depth of all the nodes. So we're given a node and given a depth. If there's a value at the node, we're going to set the value of that node in the dictionary as equal to depth. And then we're going to recursively call getDepth on the left subtree of the current node, which will have a depth 1 more than the current depth. And then similarly, we're going to get the depth of the node in the right subtree. We call this recursive function with root, and the starting depth of the root would be 0. So once we run getDepth on the root node, then this dictionary D will contain the depth of all of the nodes. So then we can get the maximum depth of all the nodes by taking the max of all the values in D. We're going to write a second recursive function. I'm going to call it helper, and it's going to run on node. This function will return the smallest subtree with deepest node for the subtree rooted at the node that it's currently being called on. So if we're calling this on something that's none, then we can just return none. Otherwise, if the depth of the node is equal to the maximum depth, that means the solution is the current node, because by itself it contains the smallest subtree with the maximum depth. We have to call the function on the left subtree of the current node and the right subtree of the current node. If we get an actual node back from both the left subtree and the right subtree, then we should return the current node, because it's a common ancestor of the left the left subtree and the right subtree. Otherwise, if we only get a value back for left or a value back for right, or we get a value back for neither, then that means only one or the other or neither has subtree contains a node with the maximum depth. So we can just return left or right. Finally, we can use the helper function and call it on root. Let's run our code. We can submit. And it was accepted.